confusion of the place, but Montreal is the right place. We're about to start. You have Joel Halpen up here helping me to run the meeting since Nick couldn't be here this time. He promised to keep me on track and on time. We'll see about that. Okay. Okay, so we have the note well. It's very early in the week. If you haven't seen it before, it's worthwhile reading. Basically, anything you say, write, post in IETF is actually counted as a contribution, and that's the gist of the note well. If you haven't read it, please read it. So as I said, Nick was not able to attend, and you will help him very kindly agree to help me share a meeting. There are audio streaming and recording, so when you speak, please speak into a mic. It doesn't matter that the 5 people closest to you actually hear what you're saying. People on the net will not hear you if you don't use the mic. You also have links to Etherpad, MeetEcho, and other things. I asked a couple of people to do Etherpad scribing, and I know that they will do that. But if you actually see anything on Etherpad that you want to add, please do that. We are basically extracting most of the minutes from the Etherpad in the end. Okay. So this is the agenda. The agenda shows 10-minute overtime. So what I've done is that I've cut 5 minutes from the working group status, and then I talked to Jeffrey to combine his 2 slots of 25 minutes into a 20-minute slot. So we should be able to finish on time. Any other comments on the agenda? Okay, so let's go. As always, blue sheets have started to circulate. Please add your name, pass it on, and when it reaches the back of the room, please check if people have actually signed by holding the blue sheet up, and if everyone has signed, hand it up to the chairs. Was there some more from that? Oh yeah, okay, fine. Go ahead. So there are a few things, actually 2 things I want to say. On Mpls IPR polls, we actually require authors and contributors to respond to the IPR poll. And we are very, very reluctant to actually go from that. But in the case where we simply can't find a person, so far, with a little bit of effort, we actually found all the people that actually need to respond when I have a document, even if they had, I think that the most 16 people actually needed to respond. But if we can't find someone, we have a mitigation plan. So it's not a blocking, but it will take time if people is not responding. And then I have a reminder. I have sent out a mail. I've told people that I think the previous 6 meeting, if you have a working group document, you are supposed to give us a progress report on that document. Unless you actually have asked for an agenda slot, or it's in some way of some kind of processing, like working group last call, or with the ISD or something like that. But the document that doesn't show anything, you should send in a meeting report in time for the meeting. Also, I can forget it. Go ahead. You haven't too much time. So We have an errata. We are discussing this, and I think that Stuart sent a mail out to the co-authors of the draft, so we need to discuss it. It's the RC 4928. But you don't need to comment on it. We just know that it's enough that we need to look at it. We can take it to the list if you want. Okay. We don't have any incoming or outgoing liaisons. So that's, yeah, that's okay. We have one new RC 8372, Mpls flow identification considerations. We have documents with the ISG. That's the Mpls spring entry label. Actually, ISG has approved it, and it should now be with the RC editor. And we have one new working group document since last time. Actually, I think it maybe made the week of the last meeting. So that's the draft IETF Mpls SFC. That document is also on the agenda. That's actually the coding in blue is, or every document that is in blue is on the agenda. So save questions that you have on documents to blue until it comes on the agenda. Okay. We have a number of documents that has been updated. Mpls MLDP Jang is actually in the process of being updated. All the others are actually posted updated. And then we have existing working group documents that haven't been changed since last time. Okay. We have a number of individual drafts that we have listed here just for information, and I think that most of those, all of them are actually on the agenda. There's one draft that, according to the name, is intended for the spring working group. And Bruno, I think we need to discuss into which working group that document actually goes. I'm having no problem in doing it in the spring, but we should agree on it. It's the draft ICPAL spring Mpls ping algo, the second one from the top. It was presented in the spring working group yesterday. Okay. So we have an LDP RMR extensions. That document is in working group adoption poll. We also have draft SU Mpls SR over IP in working group adoption poll. Both those poll will close the week after this meeting. So if you have time, interest, and the energy to do it, please read and comment on the working group adoption poll. Yeah, those are the existing documents. Yes, go on. Here we have a little bit of progress reporting. Since I'm a co-author or contributed a number of them, I actually made a list here, including those documents and some documents that I actually know something about. The Mpls LP Jang, we actually received the last IPR response as of yesterday. It only took us 3 weeks. So we know we'll go into working group last call as we go out of this meeting. The draft IETF LSP ping lag multipath and the draft IETF Mpls RI, RCP, FRR are both waiting for the working group chairs to write the Shepherd's write-up. The draft IETF Mpls MIB, MLDP MIB, is the last MIB we're doing. And Kishore, if you are here, I would like to speak to you after the meeting. That document has been installed. Also sent out the mail yesterday, and I think it's good progress. On draft IETF Mpls SRL framework and draft IETF Mpls RMR, we don't have any report. And the MLDP Yang, as I said before, it's being prepared working group's last call, basically just addressing comments from the Yang doctor.
Hello. For LDP Yang, we don't have any pending comments from Yang doctors. MLDP Yang, we are addressing Yang comments. For LDP Yang is ready for. There's no pending comments on our.
Sorry. Yeah, this is a failure to delete one paragraph.
No problem.
Okay, next. So this is a progress report we have from people sending in the progress report. The author of draft IETF Mpls summary FRR RSVPT said that they are ready to go to working group last call. I will take contact with the people with them and see what you need to do more. Next one. Tarek, that's the main author of those two drafts, base Yang and static Yang, is Tarek, and we are getting nearer to working group last call. I think that we are will have an updated version of both prior to Bangkok, and then solicit further input. Okay. Yep, that's it. So now I need my glasses. Next up is Yimin. Do we have this mic? Yeah. Yeah, there's no.
So good morning. I'd like to give an update based on the version 1 of this Mpls egress protection framework draft.
Yimin, can
yes.
you get a bit closer to the mic?
Okay.
Or shout.
Yeah. So there's only just one update in this latest version. We introduced a new stop link mode for IGP context ID advertisement, in addition to the existing proxy mode and alias mode. So in the stop link mode, a context ID is advertised by egress router and protector as a stop link IP address. So it's a very simple mode. In fact, it's a simplified version of the proxy mode. If you look at the proxy mode, which is the picture on the left, a context ID is advertised as proxy node attached to the egress router and its protector, with a link between the egress router and the context ID having a higher preference than the other link. So this provides the ideal virtual topology for the path computation for transport tunnels and the bypass tunnel. However, feedback we received from deployment was that if we could, in some simple networks or simple topologies, if we could just advertise the context ID in the manner of the stop link mode, we could still compute the right path for transport tunnels and bypass tunnels. An advantage of doing that is that for most vendors, this doesn't require any enhancements to their existing IGP implementations or configurations. So with this simple update, we believe the draft is mature and ready for working group last call. Egress protection has been in the IETF discussion for many years. We started with pseudo-wire egress protection and the layer 3 VPN egress protection. There have been deployment, implementations and deployment of both. And pseudo-wire egress protection has been published as RFC 8104. So in this draft, we're using the all the experience we've got from that, and generalize the idea as a framework. So the next few slides, I would just quickly highlight a few main points from the draft. The draft, the main goal of the draft is to provide a fast reroute framework for protecting egress node and egress link. This is equivalent to the fast reroute in transit protection, which we are all familiar with. The framework is intended to provide a generic and common architecture, which is independent of any service protocols or transport protocols. So in a environment of a multi-service and multi-transport, this will make it possible to have a set of unified solutions for egress protection. Future services and future tunnel protocols can easily fit into this framework, as long as they follow a set of guidelines provided by this draft. In terms of applicability, again, the framework is multi-service and multi-transport. Transport tunnels and bypass tunnels are decoupled. They can be set up by using the same protocol or different protocols. Layer 3 VPN egress protection is provided as an example in this draft. Pseudo-wire egress protection, which is based on this framework, has already published as RFC 8104. The framework, the draft, considers egress failure as a failure at both the service level and the transport level. So the framework addresses egress protection at both levels. The framework relies on two rows of router. First is the PRR, point of local repair. This is a router which detects an egress failure and performs a faster reroute at the transport tunnel level. The second row is called a protector. This is a router which receives rerouted packets and performs a second reroute, which is at the service level. Okay, the forwarding, this kind of reroute is also called context-based forwarding, because the forwarding is based on a service label in the context of the protector egress router's label space. The draft introduced a new notion, the notion of context ID, which is used to identify a pair of egress router and the protector. This is used to enable context-based forwarding on a protector and facilitate the bypass tunnel setup from a PRR to a protector. There are two protector models. One is called the co-located protector, and the other centralized protector. In terms of the relationship between egress protection and global repair, this draft considers egress protection as fast but temporary repair, and global repair as ultimate permanent repair. So the relationship is complementary, and they should be used together for the full coverage end to end. This is essentially the same, same as the relationship between the fast reroute in transit protection and global repair. So again, the draft is mature, and we believe it's ready for working group last call.
You mean, I actually agree with you. The draft is pretty mature, though. I will not act on anything we do on in the face-to-face meeting and on progress in the document. So one of the authors need to send an email to LIST and Mpls share requesting the working group last call.
One of the other authors.
Sorry, well, you can do it. It's just,
okay.
Yeah, it's fine.
Sure. Yeah, Robin.
Okay. Robin from Huawei. I need to clarify first. So now that is the last call or work group adoption?
It's a last call. It's already a working group document.
Working group
Yeah,
adoption.
it's we're pushing for
Okay, yeah.
publication. Yeah.
Okay, so this is the first one. And second one, I think that in the past years, I think is several things happens in IETF. So I think, for example, that's the egress protection for the tunnel. For example, for the SRMPRs, I think that any cast segment can achieve the similar purpose. This is the first one. And the second one, I think here is emphasize the context label like this way. But from my point of view, that's the domain-wide label, in fact, is a de facto standard. Can this also be incorporated in this framework?
For your first question, the other RSVP multicast draft, actually, as we work with WIMO, it actually that solution falls into this framework, fit into this management.
Okay, so this here, that's the emphasize this RSVPT, right?
Right. It fall into
Okay.
this.
Yeah, so
framework.
that's okay. And I mean
the second question I didn't.
Second one, I
Yeah,
mean, so here you means that you advertise this is the context, this forwarding. I mean, this one. I think
Okay.
in fact here that's the some to some extent that is already the domain-wide label. So because you have the context maybe for specific VPN, there's a context shared by two local PE protect each other. In fact, from my point of view, so that the whole VPN, all the PE, they can share one domain-wide label, can achieve the similar goals for the protection.
Yeah, I see. So because a protector can protect multiple egress routers. So we need one distinct label per pair of protected egress router and the protector,
So
in order to identify different label spaces.
we need to cut here. But Robin, I think those questions are fine to actually send to the list immediately, or as part of the working group last call. It's fine to do it either way.
Sure.
Yeah.
Okay.
So thank you, Jimin, and please send the mail. Andy, you're up. No, use it for where we had discussion. So before you start, Andy,
Okay.
The kind of little bit unusual layout of the agenda item 3 is up to me. Where I thought of it, we have two drafts we need to discuss. There is a kind of overlap, at least an overlap, but people need to understand how they don't overlap. So we did the discussion on the IETF Mpls SOC in London. That was a kind of 0-0 presentation. Andy will do a 0-0 presentation for draft mat. Well, 0-0, I call things that we do the first time. You only, or even whatever revision you are in, you have the right to come and say, okay, I want to do an initial presentation on this, that one, and that's what happened here. After that, Stuart will compare the two drafts, and then at the end of agenda item 3, we have a kind of open issues on .IETF Mpls SOC. So that's the way we set it up. Okay, thank you.
Okay, thank you, Loa. I'm Andy Malice. I'm talking to you about the Mpls encapsulation for the service function chaining network service header. That's a mouthful. And my co-authors are Stuart, Joel, and Vim. So this slide is a quick update for those of you who really haven't been following the work in the SFC working group. So in SFC working group, the goal is to put together chains of service functions to do processing on packets in a particular order. And that's really all you need to know. In order to make this work, they've defined a new header format called the Network Service Header, or NSH. So what this draft is talking about is how to carry packets that include the NSH over an MPLS infrastructure. And the SFC working group defines two particular kinds of boxes, shall we say, or network nodes. One of them is an SF, which is a service function. The service function is something that does work on a packet. Then there's the SFF, which is a service function forwarder. Its only job is to forward packets through the infrastructure and between service functions. So in this picture here, this picture is from the SFC architecture, RFC 7665. All I've done is added a bit of color to it. So the red nodes that you see, the SFFs, those are service function forwarders that are MPLS enabled. And so they're able to take packets that actually have an MPLS a label stack, then the network service header through the service function chain, as you can see here, from the source to the destination in a particular order over an MPLS infrastructure. So this right here is the details of the encapsulation to make this happen. So if you see in the picture on the right, you have the NSH header and payload. That's standard from the SFC working group, and it's meant to be transport independent, which means it can work on any particular type of transport. We're just defining the transport, in this case, to be an MPLS infrastructure. So to be able to carry it, it's very simple. It looks just like an MPLS VPN in that you have a single label that we're calling the SFF label. That's very simpler. That's very simple to very similar to a VPN label, for example. And then on top of that, you have the transport labels, which take you through the tunnels from one SFF to the next SFF. And one other little detail is that a destination node can have more than one SFF. So the SFF labels can actually, you can have multiple SFF labels at a destination SFF node, and that defines which particular instance of an SFF that you have at that node. And one other thing that's interesting is that this supports both normal MPLS label swapping, or you can take those transport labels and have an MPLS-SR for segment routing stack. So it supports both regular label swapping and label stacking as well. And in that particular case, it's compatible with draft Gouchard SOC and SHSR, which was presented yesterday at the Spring Working Group. So one of the things that we have to talk about is ECMP. ECMP forwarding through an MPLS infrastructure may or may not be desirable for a particular flow of packets in an SFC chain. And it all depends on the definition of the flow and the operations that are happening on the packets. In some cases, ordering may be necessary, in which case you really don't want to use ECMP if strict ordering is required as the packets go through the chain. So the way that we take care of ECMP is that the first nibble of the network service header was actually designed as an ECMP protection mechanism, in that it makes sure that that first nibble never looks like a 4 or a 6, which means that routers that perform ECMP automatically on packets that look like IPv4 or IPv6 won't perform ECMP on these packets. But in some cases, you do want to use ECMP. In those cases there, MPLS already has native mechanisms to allow ECMP to occur, both the entropy label and the flow aware transport label. The authors are still talking about which we would recommend for this particular case. We haven't quite come to a firm conclusion yet. OEM is also important for both MPLS and SFC. SFC has its own OEM mechanisms at its layer that are defined in RFC 8300. So I recommend you go look at 8300 if you're interested in OEM for SFC. We may also want to use OEM at the MPLS layer. In that case, MPLS already has its own OEM mechanisms, such as GAL, for example. Now, Stuart is going to be talking at length with the comparison between this draft and draft IETF MPLS SFC, which has a similar name. I just have a very quick introduction to the comparison. This draft transports SFC packets with the network service header between SSFs over an MPLS infrastructure. It supports all the features of SFC because it has the NSH, including per packet a metadata, which is included in that header. Now, draft IETF MPLS FCC uses the MPLS label stack to logically represent the network service header for interim deployments that don't support the NSH in an MPLS infrastructure. So there's no network service header in the packets in draft IETF MPLS SFC, and as a result, there's no per packet metadata. The only metadata that you can possibly do is per flow metadata, and that's uses either control plane extensions or a new MPLS special purpose label that carries the metadata. I've also been asked how this compares with draft shoe-clad Spring SR service programming, which was also presented yesterday in the Spring Working Group. So this draft, again, transports FCC packets with the NSH, supports both traditional label swapping and SR MPLS, as I said before. Now, this has the usual MPLS state in every node because it's regular MPLS. So there's the lib and everything else at every LSR when you're doing label swapping. And this is really intended for SFC infrastructures with MPLS, and the FCC NSH is present in every packet. Now, draft shoe-clad is quite different in that it is tended to support generalized service programming in segment routed domains. So segment routing only. Services are associated with SIDs, and this is actually a bit more general and more powerful than what's happening in SFC, in that services could be more than just the service functions as defined by the FCC working group. Draft shoe-clad works with both segment routing MPLS and SRv6. It does not support MPLS label swapping because there's no MPLS state in the routers. It only supports the label stacking. And the NSH is available for use by the use of a TLV. So the next steps for this draft, we have some more work to do for future study items such as the ECMP and control plane. And since I wrote this draft, we've actually had more progress on the control plane. We've been working with the authors of draft IETF BESS NSH BGP control plane, and we've already determined that that draft already has everything that's needed to support this draft. So we really don't actually need to make any changes to the best draft to support this draft here. It's already all done. And there may be other control plane options as well. And we want to start working towards adoption here. Any questions?
Adrian Farrell. So firstly, apology to Andy, because when I first saw this draft, I had conniptions, and then exchanged email with Andy and Stuart, who calmed me down. This is something we need, right? You cannot carry NSH over an MPLS network without an encapsulation. We need it. So good. And one point of interest, this SFF label advertisement, we've been looking at the BGP control plane work, as Andy says, and as luck in the script would have it, we already support this function. So we need to add a pointer, but then we're done. Oh, sorry, a pointer to the document.
Yes. Any other questions? Okay, thank you.
Okay, thank you, Andy. There's one, Wim.
Oh, wait a minute.
Just one comment on the control plane. I think the draft supports it, but it's not explicitly written, right? On
Right.
how to do that. So I think there needs to be a bit more text on how we would support that with the control plane. But the semantics are there.
Yep.
But I think there needs a bit more text to actually clarify that. On
Okay,
how it
great,
would be
thanks.
supported.
Okay, and it's Stuart's turn.
Okay, hopefully quick. So I was asked to compare the two drafts, this draft and Adrian's draft. So to summarize, draft IETF MPLS SFC emulates NSH operation in an MPLS environment that does not support native NSH operations. It uses the existing MPLS forwarding plane to send packets to and between service functions. SFFs, the service function forwarders, are built using existing MPLS routers. It's designed to provide a migration assistance to an NSH environment, making it easy to introduce service function chains in today's networks. The MPLS layer has to understand the whole of the service chain to make this work. So the service chain is fundamentally built into the MPLS layer. Draft Mullis MPLS SFC encapsulation is designed to carry NSH packets over an MPLS network between SFFs. So the MPLS layer does not have to understand service function chains. It's just acting as a transport between entities that do understand the NSH. And it operates really like a style of MPLS VPN. There's a label in there that vectors the packet once it's arrived at the node into the subsystem that understands the NSH. And there may be more than one of those. So they're like chalk and cheese. People question the use of this expression. It's an expression that goes back to the 14th century and avoids me giving a preference to any particular computer manufacturer. So they are completely different, is what it means. The draft IETF MPLS SFC understands and knows the service chains. Draft Mullis MPLS SFC encapsulation understands how to deliver packets to an SFF, but not what to do next. Neither can do the job of the other. So here's what I think we should do. Each draft has a different purpose and is applicable to a different network scenario. There's no conflict between the drafts. Each draft needs to be considered on its own merits independently and for its own purpose. Draft IETF MPLS SFC is a working group draft. It should continue on that path to normal publication. The draft Mullis is not yet a working group draft, but I think it's actually simple enough that we should adopt it soon. And then both drafts should follow their natural progress to publication. And that really is the end of the story. Any questions?
So, Stuart, what you're actually telling me is that there is no need to actually do the progress of the draft in relation to one to the other. You can do them in quite totally independent.
Yeah.
Okay, thank you.
It's completely separate problems, they're just ordinary drafts.
Okay, thanks.
Okay,
Robin.
Robin from Huawei. I need one thing to be clarified. So regarding this, you under the Mullis draft, I not understand this the SFF label to identify as service instance, right?
What the label does is to say the packet that's being encapsulated contains an NSH. Send it to your NSH handler.
That means yeah, but
then the NSH handler understands the whole service function chain system. It is the thing that understands how to do the SFF function. It knows how to send the packet off to the service function actual sort of itself. So all we're doing is we're just transporting an NSH over an MPLS network and then handing the packet off to something that understands how to parse an NSH.
Okay, that means the SFF pass, not the SF pass, right?
Yes.
Okay, yeah, right. Okay.
Hi, Stuart. Jim Geisha, Huawei. I just want to make the comment, let's not overcomplicate this.
Yes.
There's a concept in networking called layering that we seem to have forgotten, but you know, let's understand it's still there. This draft simply says, I get to an end of an MPLS stack, I have something, I need to know what the heck it is. This label tells me it's an NSH packet.
Yep.
That's it.
That's it.
As simple as that.
That's it.
Okay, thank you, Stuart. Adrian, you're up. Adrian, did you have the... Yeah.
As the slides appear, I'm Adrian. I don't intend introducing this draft. Because we've been there before, what I want to do is flag up some of the issues that were raised on the list, how we have addressed them, and what's still open as an issue. And then I will stand here while you throw things at me. Yeah, chalk, cheese, vegetables, coin. Yeah, coins, definitely money. At this point, if Tarek was being really honest, he'd say, had Adrian sent the slides sooner, he might have better organization. They're very nice slides. So summarizing the use cases from memory, the problems from memory, the first one was there even any need for this work? Now, I think the fact that we've adopted into the working group, we're probably over that, but the aim was to get the document to be a little bit clearer about what the deployment scenario was. And this is not competing with the work of the SFC working group. It's not saying the NSH is rubbish. What it's actually doing is saying that there are brownfield deployments which are MPLS capable already, and we want to see if we can get some of the functionality of the NSH into an MPLS network so that existing MPLS routers can act as service function forwarders. That, if you like, is a bootstrap to service function chaining. And will it ever happen, or will we go straight to NSH? I'm not predicting the market on that, but I wanted to enable this, and turns out it can be done and works. Thank you. I have control. Great. These were then the 3 points I just talked about. Brownfield. What are the use cases to this encoding? How does that affect swapping or stacking? And then to resolve the conflict or the overlap with the SRMPLS SFC approach that is in the Spring Working Group. I've already talked quite a lot about the brownfield. The point was to have NSH unaware SFFs, so the forwarders are just MPLS routers. And to highlight again, this is not the end goal. We're not saying forever everything will be an MPLS network. We're trying to get service function training going with what's already in the field. So what we did with this was added some text in the abstract and the introduction to try to drive that point home. And we wrote section 14 as a sort of proof of concept straw man thing that says, this is a way it could be done. It's not a recommendation on how to do it, but people were saying, oh, you can't do it with existing MPLS routers. And we know we can because we can. So what I tried to do was write here's a way you could do it, essentially using the VRF model of labels. It's just a proof of concept. If anybody actually does implement it like that and deploy it, I shall be surprised. But I just wanted to show it could be done. So that's the brownfield. The next thing was to say, look, what are the use cases for stacking and swapping? And so we added section 4, which lists 5 specific cases. The first one is the standard. It looks very much like the, that's interesting, NHS. I've got the British Health Service on my mind. The NSH is mapped into 2 MPLS label entries, and then it's treated just like an NSH at different nodes. It's looked up, it's swapped. So that's kind of using the MPLS label swapping, but it's also very close to the NSH. The second use case was to say, we want to do that, but sometimes when we arrive at an SFF, there's a choice of service function instances. And normally you'd let the SFF choose based on load balancing or time of day or the weather or whatever. Sometimes the classifier right at the start will want to control which service function instance a particular packet or flow goes through. You can do that by having the NSH labels and then underneath another pair of NSH labels to actually get you into the right SFI. So that actually gives you a need to stack these entities. The third use case is hierarchical SFC, or I think the draft is called hierarchical NSH in the SFC working group. And that's essentially NSH nested inside NSH, which if you like, you could call NSH stacking. And obviously when you map that to MPLS, you end up with stacked MPLS label entities. What this achieves for you is the ability to concatenate service function chains, which turns out to be a really neat property, both for scaling, but also for achieving compound functions. Right, the fourth use case then is a kind of reduction of that previous case. If you imagine a chain, 2 chains, both 4 nodes long, well, you could actually have a chain that's 2 nodes long and maybe 4 of them, or you could have 8 chains that are just 1 node long. So you end up potentially with something that looks like a label stack entry for each SFF you're going to. And that is the one that causes the conflict, because that starts to bump into SRMPLS. And what we've written in this document, I hope clearly, but willing to make more edits, is to say, look, SRMPLS is not in scope here. Go look at draft Shuklad about that. We're not trying to do SRMPLS for service function chaining, but it just happens that the obvious extension of any label stacking is to end up with something that could look really similar. So that led to some discussion on the list, and the blue text is a quote from a couple of emails on the list. I don't think, I mean, we're welcome to do it, but I don't think there's particular value in having the debate about when did label popping and steering and so on first come about, because that might just lead to lots of time spent going through the archives and lots of blood on the floor, where what we really want to do is look at the ways forward. So for me, as I just said, the microchain concept is a consequence of supporting any hierarchical SFC. So as soon as we have hierarchical SFC, it is possible to do microchains. That does not mean it's a good idea, but it's possible. So how do we get around this in the document? How do we move on and get over any upset or conflict? So I've got 4 options. The first is just stop talking about microchains. So that's section 4.4, delete it. It doesn't mean that you cannot do microchains, it's just we don't flag it. So maybe people wouldn't notice. Second option is to explicitly forbid microchains. And I'm not quite sure how that works, because where do you draw the line? Is a 2-hop chain too short? Is a 4-hop chain too... at some point, we would have to decide what constitutes a microchain. And in any case, how would you police it? Because it's just a natural consequence of any hierarchical SFC. And so would you end up forbidding all hierarchical SFC, which would, I think, seriously constrain the function? Third option, keep 4.4, but actually point it out to SRMPLS as well. So if you want to do single hop microchains, don't do it like this, go off to SRMPLS. And the fourth option is to say, well, actually, SRMPLS is more than just the forwarding plane. SRMPLS is the whole control plane construct as well. Maybe highlight that a bit more, and then otherwise leave the text as it is. And the fifth option is listen to Andy.
Andy Mellis, I would prefer personally your third option, to add the text.
Because? I'm not an attack because, but just for my benefit.
Oh, sure.
Why?
Because as you said, you know, it's functionally identical to SRMPLS. So just include the text which points to the single hop microchains. You know, just add text to section 4.4, which points to SRMPLS, and the text that you said that you're not doing SRMPLS.
Okay, yeah, it does. Is the rest of the room just kind of glazed over here, or no, Jim's got something as well. So Andy, I'm going to come back to you if the rest of the room is saying, yeah, that's the right way to go, with help, let's sit together and write the text.
Jungi, sure. Adrian, I'm not quite sure what the problem is, because on the wire, I can do exactly this with NSH. It just doesn't look like an MPLS label stack. It looks like a NSH label stack. It's still a label stack. So do we really care?
Well, patently people did really care because they got agitated on the mailing list.
But why? Just because if you look on the wire, this looks exactly the same as it's a label stack, the same as SRMPLS is a label stack, but
right, and I think it's kind of
to set it up are completely different.
Yeah. So on the wire, it's, as I say, the methods to set it up, the control plane are very different. But when you come and look at it on the wire, it looks very similar. And I think what happened was two groups of people or two documents, one working from one end, which was the pure, just single NSH, if you like, swapping, and one working from the other end, which was the pure SR MPLS, and they come together in the middle. And do we document both approaches? Well, sorry, do we document the same result in two documents, or what? And that's, I think, the problem. And yeah, Andy's solution may just cover this, because it doesn't prohibit this, but it says, look, here's a way of achieving the same result.
And the other comment I had is, what do you mean by the comment forbid hierarchical SFC? I mean, from an SFC working group perspective, that's clearly not going to happen, because that document is nearly an RFC anyways.
Within the context of this MPLS representation. Yeah.
So I think your second option, explicitly forbid microscale chains, doesn't really have any intellectual sort of validity at all. I mean, clearly you can do it, and if you can do it and someone finds a need to do it, they will do it. So why would we write an RFC that we know that at some stage someone might have to write a one-line RFC to modify to allow something that is perfectly allowable? So I don't really understand quite what the fuss is about, to be honest. The functionality is useful. People will use it for whatever they think solves their network problems. Let the market figure it out.
So, Stuart, would you object if we did the option 3 that Andy was advocating?
Add text to point single hop.
So basically, section 4.4 as it is, which talks about the single hop microchain, would mainly continue with the text as it is, but then would also have a pointer to draft Schucklad.
If people want to go and read that draft and look at the alternatives, I think, again, that's an intellectually valid thing to do, and they should make up their mind as to what suits their needs best.
Okay, if I may preempt the chairs and say, is there anybody in the room who would object if we did that third option? And possibly, is there anybody in the room who's awake? Yeah.
I'll be happy to help you with the text.
Thank you. So otherwise, it's business as usual, raise issues as you see them.
Thank you, Megan. And Robin? Robin, you're up. Robin, are you in the room? Yeah. So let's see. Oh. Yeah. So we move on to, again, the item 5. I think Harish is going to do the presentation. Is that right? Yeah.
So hi, Harish. I just wanted to give a quick update to this
Harish,
work.
you need to get close to the mic. It's a little bit inside.
Swallow the mic.
Yeah.
Oh, okay. So giving an update on this IETF working group document. There's O2 version. Okay. So very minimal updates were done in this version. So we mostly editorial. So we added some more terminology to make certain parts of the document more clearer. We had the effective transport label depth computation. We made it a little bit more clearer. What does it mean to set IETLD if it had link protection in it? There were a few editorial nits in the IANA section. We basically cleaned up the document. So we received early allocation code points from IANA. And in the original version, way back on this document, we had a section on node protection, which wasn't written up. So there was a separate draft that was published to deal with some of the details of node protection. And I'll be going over that next. And the draft has been stable for a while now. There is at least one implementation that's been shipping. And so that's the current status. So at the moment, we just asked for additional review, and we feel the document is actually ready for working group last call, and it's been fairly stable. So
Questions, comments? Otherwise, we move to the next agenda, which is you again. Bring up the next slide.
So, sorry, I missed the last slide. But did you ask for it?
So ask for additional working group feedback
Okay.
and
Again, you need to send the mail to share and the list to say that you're ready working with us.
okay, we'll do. So in sort of continuation from the base draft, we published a new draft for node protection. It was originally part of the base draft, then pulled it out. So we wanted to add more details. So what's the basic motivation, right? So the base draft offers you an ability. It introduces the concept of T-link labels, which can be stacked. It also introduced the concept of delegation labels and hops in the base draft. So one could create a stack of labels and sort of reduce a data plane footprint for RSVP LSPs. It also included guidelines for setting up such LSPs which do not require any protection and LSPs that only ask for link protection. So this draft is basically for offering node protection on that same transport LSP. So what is the issue? Why do we need something different? So if you just take a look at the picture, right? So B is the PLR, D and E are merge points. So they are next stop LSRs. So with T-link labels, LSPs actually share the labels. So label 100 at B is actually can be shared by many LSPs heading towards C. With node protection, the merge points are different. So B cannot use 100 for any LSP going towards C on that link because the next stop is completely different. So the bypass LSPs at B to protect these LSPs heading towards D and E are completely different. One is at the top red line, the other one is at the bottom red line. So you can't have two different backup forwarding actions for the same label. You don't know which traffic is going where. So that's basically the problem. And you can share that label 100 only if LSPs actually share the same next stop merge point. So for LSPs going from B to C to D, yes, absolutely, you can share the same label because they can all pick the same node protecting bypass. And similarly, BCE, LSPs heading down that direction can actually share the same label. So with the procedures as such we have come up with, in this diagram, it's easy to envision C as being a PLR. We'll just go through one simple example. The rest sort of very similar. So if you look at the labels between C and D, 348 and 345, you have to allocate a label for that link for up to your next stop radius. So for LSPs, because RSVP has the ERO and RRO, every node knows where the LSP is heading towards, where the LSP is going. So if C is a PLR and it knows an LSP is heading towards E, for example, C, D, E. So for all LSPs heading via D to E, you allocate a single label, and then via D to H, you allocate a different label. So at the next stop radius level, the scale increases. It's not just flatly for the number of links. So the original base draft had number of labels allocated by C is equal to the number of links that you have. And now it slightly goes higher because it goes up to the next stop radius level. With respect to the forwarding action, the basic primary forwarding action remains the same. You pop and forward down, C pops and forwards down CD. For backup forwarding action, you would have to pop two labels and then push the packet down and then the node protecting bypass to the merge point. Similarly, you can see for the other examples, the draft gives you clears up the picture, gives you all the labels. So this is actually an example where, like in the base draft, we have this concept delegation label and hops. This is a very straightforward example. If there is no delegation hops in this example, it's a very simple example which says CDE, none of them are delegation hops. C is a PLR, E is a merge point. What happens if there is a delegation hop? So just to recap, a delegation hop is a node that actually, it is a transit node that actually helps stack a set of labels because ingress is unable to reach all the way to the egress. So a router in the middle of the network is actually stacking labels. We've introduced, the base draft talked about the ETLD algorithm, what is ETLD, how it's used to automatically select delegation hops. So much of what I'm talking about doesn't apply for explicit delegation. This is all automatic delegation. So hops get selected down the middle. So if you take this example, we have a C is a delegation hop. For example, it's going to push a lot of labels to take the packet downstream to the next delegation hop, which is E. So to C to E, there's a label stack. So for that's the protected node. So if you have to protect a delegation hop, the PLR B needs to be able to push all the labels that C actually pushes. So that's the base condition. So, but B, if the label capabilities, if push capabilities of all these devices are actually very good, like they're very high, equal or greater, then B can certainly push all the labels that C can push. But if B cannot push all the labels that C can push, because B may not have a depth push capability that C has. So let's say C is able to push 4 labels and B can only push 2. B cannot, as a PLR, push all the labels that C does. So there is this new, we had this ETLD attributes TLB in the base draft, it was 32 bits. So we took another 8 bits from it called delegation helper. So B actually tells C how much labels it can push. And it can actually see, in fact, the ETLD algorithm is actually changed at C. It changed it such that it uses the DHLD coming from the upstream hop to decide what the outgoing ETLD should be. So that C enables node protection for the PLR. So that's the basic change that was made. So the ETLD at C basically is computed using a min of the DHLD coming from the previous hop and what ETLD it may have naturally computed. So whichever is the lower value, it takes it. The forwarding action pretty much looks the same. So C PLR would have normally popped and forwarded down the link. For the bypass, it actually pops the label, pops 2 labels and pushes the label stack that the protected node would have pushed, the delegation hop would have pushed, and then sends it across the bypass. So that's how this works. And for backwards compatibility, so either like, an implementation may have implemented the base draft and doesn't support what we are recommending in the node protection draft, or implementation doesn't support. So in that situation, right, so the DHLD coming from B to C doesn't even understand what DHLD means. So it does what it does as described by the base draft. It sets the ETLD as normally as it does. B looks at the RRO, because B is the one that's supposed to create the label stack and push it in the bypass. When B looks at the label stack and looks at it, it looks very large. It simply cannot push such a large label stack. So B can resort to using link protection for it once. So much of these are easily detectable via the signaling plane. So B can choose to offer no protection if it wants, or choose to step down and offer link protection in these scenarios. So that's the document. At this stage, we just request working group feedback. It's at the 0.0 version of document. Jeff.
So in LSR, I still need to get used to the name. We are working on machinery to distribute information about what's supported by not by link, which includes amount of label that could be imposed, amount of label that could be read. Potentially, it's more information that you could gather. Maybe you could use it because we flood it anyway.
Right. So the MSD
plus ERLD.
Yeah. So this that can certainly be used. So this much of all of this is for this automatic delegation mode that we have, where there's maybe you don't have a controller, maybe it's distributed. But if you do have a centralized place where it's flooded and kept, certainly
yes, practically you get much more data and context. So, thank you.
So one comment in your last slide. It's okay to request feedback, but I think you need to be active also, actually asking people that you think have some expertise in this area to actually review. So you actually, and ask them to send that feedback to the MPLS list also.
Okay.
Any further questions? Okay, so then we are back to Robin. Suddenly showed up.
Robin for Huawei.
Robin, I'm a bit nervous about this presentation because it's fairly long, fairly complicated, and you only have 10 minutes.
Okay.
So we need to cut you off at 10 minutes, so think about that. Yeah, that one.
Sorry, this is Robin. To be honest, I'm a little scared, so for relax, but miss the presentation. Sorry. So this one, my topic is the Mpls path programming. So in fact, this I have a much relationship with discussed SFC work. In fact, to be true, that's before this one, I assume that the Hao Yu will present his Mpls extension header because this has much with relationship with this work. But anyway, I can talk this firstly. Okay. So this, I think this the segment routing has been proposed. So this is utilize the Mpls programming capability very well. So this document to summarize the use cases and the possible future of the Mpls path programming. Okay, so first, this is a history review. In fact, Mpls label stack in the past years before segment routing is also existed. We list here. At that time I proposed that at least we have some of these most complex cases that is VPN over BGP, over LDP, over RSVPT, and over the bypass fast route. It can achieve to the 5 layers label. Yeah, but when it go to the, and also that in the history, we also have some of these labels we think is beyond the reachability. Because at the beginning, we based on this, the Mpls label for the reachability. But in fact, we have some of this, label capability is not to indicate reachability, but to indicate some of this, the service. For example, the interval label or the flow label is for the ECMP. Okay. So now that's the Mpls programming. This is now developed very fast. We think that there's two important factors. The first is that the central control is adopted, so that is easier to allocate label for more purpose than reachability. Second one is based on central control, is easy to calculate the Mpls path. Yeah, so this is the way thinking on this one. So that's we also here we mentioned that's the Mpls programming beyond the segment routing. From my point of view, that's the Mpls programming. We have this two layer. The first is a transport layer. So this is the most for the reachability. That's the best effort path, and also this is the traffic engineering path. This we based on the segment routing. And now that we think that is the important work is the service layer and the network layer. This means that is for specific flow. That is we use the Mpls label to indicate serials of the service process. That means is along with the specific prefix which indicate specific flow. Yeah. So here we have this we think if we think about the transport layer Mpls programming, we think that's the segment routing, but the service-oriented Mpls path programming. So this we think some of this is the new work. Okay, so here we list several use cases that is related with the unicast cases or the multicast cases. I will not introduce the details. I directly finish this the architecture. So here we can see that's the Mpls. We have this the service label. I think now that we have the entropy label, and we have the that's the source label or synonymous flow label for the OEM, and also steering label, and also now that in some this is the bandwidth guaranteed label for the network slicing. And also we maybe the future we have this the queues label with the label to indicate the queues process. This has been happened in the Mpls history, such as the LSP. And also this is the VPN label to indicate a specific VPN. So based on this service label, it can be flexibly programmed along with the prefix. So here we can say for specific prefix, it has a multi-label to indicate a serious process for the ECMP, for the OEM, for the queues, like this one. And also is can be steering into a specific tunnel. So this is the new capability for the SOMPP. And also this is the architecture, this is based on the central control. So this is including how to allocate this the service label in the Mpls domain. And also that is after this the programming for the service path and is download to the ingress node with this the prefix. So we think this the BGP is suitable for this purpose. Okay. Okay, so here this is the picture to show this one. Maybe this is the similar, but here we can see this is download this label. So we can see this is the destination at that time for specific VPN. So this is only the VPN label, but this is not only the VPN label, but with the service label stack. Yeah, and also here it can also specific tunnel. Yeah. Okay, so this is the scenario for this one. So we give here this two typical use cases. So this is the steering, this is the prefix to a specific tunnel. At the beginning, maybe this is the red one for the path, but later maybe this congestion happens. So based on the PCE initiated, we set up a new LSP or the new SR path. And at this time, based on the BGP for the SOMPP, so that is download and to specify that this is the flow to this is the red path. So this is to the determine this is the redirect to a specific tunnel. And here this is another is determine the ECMP with entropy label, because now that for the entropy label is always calculated in the ingress router based on this the IP destination address and also this the source address to that one. So this can solve to some extent can solve the issue of this elephant flow and make it distributed. But in fact, it's because the ingress router is lack the global view of the network. So this maybe also has some, this is not reliable for the ECMP. But with the central control, it has a global view, So then it can calculate specific entropy label and download with this the prefix. So this can be for the better or the optimal the ECMP in the network. So this is more determined in the network for the traffic pattern. Yeah. Okay, so and also this is the last pages. This is the overview of the progress of the related work of the S1PP. In fact, the 3.5 years ago, I proposed this the two draft. One is in the Spring Working Group to specify this concept and solution, and at the same time we specify this the BGP extension for this purpose. But after that one, it's almost stuck because I have much other work. Now we think this is the right time to resume this work. The first one, we change it to the Mpls working group. So we think this is the right home for the solution. And the second one, we can see this we made much progress in the past years. We can see this the Mpls service label existing the entropy and also the synonymous flow label for the OEM that is becoming the RFC. And also now that we propose some this path segment, this for the OEM or the bidirectional for the SR work. And also we have the VPN, this label to use the label to specific VPN, and also the Yeah, so this, based on this one, but we can identify this, the requirements of the challenges. So now that most of the label wanted to put it at the bottom of the label stack. So that's we say that that time flow label wants the bottom, and also the SFC, they also the bottom of the label stack. So now I think here we must determine the forwarding plane. So which should be the bottom label, should be bottom label. This we think should be defined in the Mpls working group. Second one, so that is the Mpls extension header work, because we take at that time only the Mpls label stack, but as the SFC and the LM, so that means between the label stack and also the payload, you must take some of this metadata. So that's how to take the metadata with this with the Mpls label stack. So here we define identify this requirement and propose this possible solution and how you will present this one in the next presentation. Yeah. And also this is related with the BGP extension. I think at that time we proposed this one for the IDR, but later I think the Eric Rosen, etc., they do some work on this one. This is a tunnel encapsulation and to specific tunnel to redirect this flow to a specific tunnel. And also here they also to identify.
You had to sum up.
Okay, yeah. Okay, sure. Okay, so that's almost all. So that's only the requirement is to download this the ID programming. Now that's not only the Mpls programming. Okay, so summary this I will in the next version we will revise the draft to consolidate the solution with the latest progress in the IETF, and also revise the draft of the IDR extension to consolidate the BGP extension. So after that is solicit more comments and feedbacks. Okay. Yeah.
So any questions?
Okay. Yeah.
And try to make it short.
Sure. Robin, I recall seeing the slides at least twice in my life as if you're stating the obvious, and it's not really architectural framework either. You could go left, you could go right, you could jump high. What is it you are trying to achieve?
Sorry.
No. Why are you presenting this slide? Simple question.
Okay, yeah.
Third time.
Sorry?
Third time.
Third time?
Yes.
What's third time? You mean my presentation is third time?
I've seen it before.
You seen this before? Who? Because I think this is when I joined this the IETF work that is 10 years ago, I not see this work. But maybe you have.
You presented the different working group. So you're mentioning a lot of stuff, and most of it is obvious. It's there. We are using it today. Your draft doesn't read as an architectural document, so how you put different pieces and make a service work. What is your end goal with presentation of this draft?
I think the answer to that is actually we need to take that discussion on the list.
Okay.
If you have a short question, that's fine.
Daniel Bernier, Bell Canada, it's almost the same
Close to the
comment. Daniel Bernier, Bell Canada, almost the same comment is, I'd like to see what this draft can actually fix, which other drafts are not actually trying to fix, like SR, SFC, or the draft ZooClad or segment routing policy. What out of all those working group documents is not covered that this is actually trying to address? If not, I try to see how it can be merged, because
So I guess that we ask Robin to go to the list and actually list what's new.
Yeah, sure.
Okay.
I will give.
Now we have Italo. It's a long time since you had a presentation in Mpls working group. back in Maastricht, or So what about the blue sheets? Where are they? Who have them? Can you kind of walk up and see if there's anyone that hasn't signed them?
Okay, can I start?
Yeah.
Okay, thank you, Mr. Chair. I'm Italo Busi from Huawei, and this draft has been submitted to the PAS working group and is trying to discuss what is the problem. The problem is the situation.
Sorry, wait a minute. I should have said that before you
Oh,
started.
sorry.
We have a short interrupt of the Mpls working group, and we're actually now doing a Mpls presentation hosted by the Mpls working group. So please go ahead.
Thank you. And what is the problem we're trying to solve is a case where we have a network where one of the two TPs is at least one of the two is not capable to insert the control word, and we want to find a way to be able to send packets over the network with the control word. The reason is that the latest draft that has been approved recently by PAS is recommending the use of the control word with Ethernet pseudo wires. However, if one of the two TPs is not able to insert the control word, there is nothing we can do. The control word will not be sent over the network. And one option that was discussed at that time was to replace the older piece of equipment. And this option is not precluded by our draft. But we were looking to some alternative solutions that can allow operators not to replace the old equipment if they don't want to do that because of operational or economical reasons. This option is not always preferred by the operator. So we were looking if there is another way to solve the problem without replacing the box. And what is the proposal in the draft is basically to add a new SPE in the network to place this new SPE in a very close location to TP1. So what happens is that in this situation, you have one link or a very small size network. We expect to be co-located or one hop away at the MPLS layer, where you can control there is no ECMP between the TPE and the SPE. And then to change the behavior of the SPE to be able to receive packets, pseudo-wire packets without control word, and send them over a pseudo-wire segment where a control word is enabled. By doing that, you control no ECMP behavior here, so no problem not having a control word, and you have the control word that protects against incorrect ECMP behavior when the traffic flows through the MPLS network. Once you have set up this multi-segment pseudo-wire, then if you want, you can move the traffic from the old pseudo-wire to the new pseudo-wire using pseudo-wire redundancy mechanisms, which are already defined by the PAS working group, and that will be, the service interruption will be minimal. The big assumption that we have in the draft is that the behavior of TP1 is independent from the fact that it's terminating a single segment pseudo-wire or a multi-segment pseudo-wire as outlined in RFC 6073. And okay, a few slides since it's the 00 draft that describe the basic approach. So SP1 is receiving a packet generated by TP1 without the control word. The operation of SP1 are the same as of today. Swap the pseudo-wire label, decrement the TTL, but in addition, it inserts the control word before sending the packet to TP2, and in the opposite direction, it removes the control word before sending it back to TP1. And the VCCV is teaching, so you have also, since you modified the data plane encapsulation, also the VCCV options available on the two segments are different. We assume, for simplification in the draft, that we can always use CC type 1 over the pseudo-wire that has the control word. So we limit the number of options to address only to CC type 3 and 4 on the first pseudo-wire, and in this slide I'll only address type 3. If you are interested to type 4, you can read in the draft. And basically the solution is the same. Swap the label, recommend the TL, and you insert the ACH. And here is importance is, yes, TC type 3 is that SP1 knows the TTL distance it has between to TP2 to TP1, because the TTL is the discriminating factor to distinguish whether the packet is a data plane packet, so you need to insert the control word, or the packet is an OEM packet, and you need to insert the ACH. And this is describing a bit the signaling procedure, so the LDP signaling to negotiate. So the SP1 can negotiate no control word with TP1, and can negotiate control word, use of control word with TP2. The key issue here is that the changes that we are requesting is on the behavior, on the protocol behavior of SP1. From TP1 and TP2, nothing changes, so you don't have to change anything in the control plane for TP1 and TP2. You have only to change some rules to allow SP1 to negotiate different control word capabilities on the two segments. And the same applies to the VCCV type. So you have to negotiate different CC types. And you have an additional rule here not to negotiate ACH CV types if you don't if you're not able to translate CC type 4. And this is there are some corner cases when you have the CC type 3 and 4 on TP1 and TP2 that you can enable CC type 3 and have ACH not supported enabled. And last slide, the solution is described with one SP, but the operation of the SP is independent from how many pseudowire segments do you have in your network. So you can have additional deployment scenarios. One is in case where both TPs are not capable to insert the control word. The solution is quite straightforward, just add the two TPs and everything works. Every SP works as defined in the draft. And you again enable sending traffic with control word through the network. And the last case is when you have a more complex scenario, you have, for example, Mpls TP networks where you don't have ECMP. You can also put the SP that insert the control word a little bit far ahead in the network, because as long as you know that your network or multiple networks are not, are you sure that there is no ECMP? It doesn't matter. As long as you can send control no ECMP, you can send the traffic without control word as far as you like. It's very generic, and you can have as many SP as you like through all your chain. The behavior is only limited to this single node. So what are the next steps? What we would like to, first of all, to understand the current, there are assumptions because we don't want to boil the ocean with all the corner cases, sub-corner cases, and so on. And so we need to understand whether the current assumptions are realistic. First assumption is this a problem we are really going to face in the network? So how many devices are currently in the network which are not capable to insert the control word? If they are in the network, the more they are, the more important is to have this type of solution. And the second, what are their capabilities? What they can do when you have multi-segment zero wire in terms of CC type, CV types, and TTL configuration. Because these are the assumptions that we have on the behavior of TP1 that allows the solution to work. And of course, we accept and welcome any comments and proposals to improve. Thank you.
Justin Suranosh. So elegant solution to solve the problem. The question, I assume your work is driven by DetNet requirements with regards to control word.
Yes.
So
yeah, the requirement is this one, yeah.
Yeah, otherwise, I don't think we really care about control word today. The point being, part of your network doesn't have control word and part does. So part of your network is undeterministic, and I would question whether it's good enough for DetNet service to provide network that split into one is undeterministic, could be CMP, could do many things that we don't want to do in DetNet, while another is, could you treat it as a single service? Do we really solve the problem for DetNet doing this?
Okay, DetNet, I'm not aware of DetNet. But I think the key point is, what do you do when you have a box which doesn't insert a control word? And your network still does ECMP. That's the key problem.
Yeah, I understand. So yeah. if it's not DetNet related use case, it solves the problem.
Yes.
If it is, I would question whether having a network that's split in two is good enough for DetNet.
Split in two, but means that the network without a control word, you don't have ECMP.
No.
Okay.
Without control word, you would have ECMP.
And you don't have services between these two networks?
The service is end-to-end between TP1 and TP2 with SP in between.
Yeah.
So question to DetNet
people,
whether it solves their problem.
Then you go to this deployment. So where you have this network is without control word and no ECMP, but this network is with control with ECMP. But if you have a service that goes end to end, how do you ensure that there is control word in this portion of the network?
Yeah, it's kind of problematic.
Then you need to basically apply the solution to an existing SPA. So the solution will work on a different deployment.
I'm not sure, maybe a comment from one of the Mpls share, but this is actually targeted for a Mpls problem, not for a DetNet problem.
Yeah.
So if DetNet actually needs to have a documentation of their own, and I think they have. So I don't think it's an issue.
No, so they do state that they require control word to be present, right?
Sure, but it's actually documented in another document.
So if you could address it.
So look, this is solving a historical problem, right? When we wrote we were told by the operators that not having a control word resulted in ECMP of some sorts of Ethernet packets, and this was a problem. So we wrote a draft. And in the draft, which is now on track to be an RFC, we basically say, really try hard to put the control word in place. Now, some vendors have got deployments and they can't actually change those deployments. And so the question was there anything we could do for operators that had deployed equipment that they could not change to at least minimize the effect on the rest of their network? And so the proposition is that we put a proxy there. But for all new equipment, I absolutely think putting the control word in there for DetNet, I think you'd be insane not to put the control word in unless you really were in trouble.
So the question is really
Actually, yes. Now we are in a take it to the list situation, and
Yeah. So first,
And
of
actually,
my,
add this
I
to
have
the
two
PALS
questions.
list.
So
it's not MPLS.
yeah, one is, do you know of any merchant silicons that support inserting and removing the control word at switching PE in the data plane? It's very difficult. Huh? Yeah, it would be very difficult to support that. Secondly, the sequence numbers, you haven't mentioned whether the sequence numbers are included
so
in
now
it or
I
not.
think the complexity of this question is such that you have crossed it on the list.
Yeah, okay.
Thank you very much.
Good question
Okay.
anyway, the person we
Move ahead.
can talk about that.
Will PALS share, would you wait? Okay, thank you.
Thank you.
And now we are, Jeffrey. Yeah.
Okay, I can get started first. Resilient multicast has been discussed in this group for quite a while, but the focus before was on unicast. And today I'm going to talk about the multicast aspects of it. There are two slides, the two presentations and two drafts. The first one is focused on RCPT P2B tunnel. Let me start with the traditional RCPT P2B tunnel signaling. I'm using this example here, the ring topology. For P2B tunnel, you have many leaves, and typically for each leaf, there will be one sub LSP. In this example, we have one ring with R1 as the ingress and R2, 3, 4 as the tunnel leaves. So R1 will set up 3 sub LSPs. So when it's near the ingress, you will have a lot of path residue state. And each sub LSP optionally could have its own explicit path. And additionally, the actual state for the tunnel protection is needed when you set up a bypass tunnels or protection tunnels. So all those could be optimized away when you have, in the case of the RMR. So the optimizations we talk about here are include that we will only need one single LSP in most scenarios. So the ingress router R1 could decide that to just use a single SP in one direction for all the leaves that goes around the ring. And with that, you only need one single pair of path residue states on each node that is on the tunnel. Optionally, the R1 could say that I'm going to set up two sub-LSPs in two directions so that different leaves can be reached in the different directions. Notice that this is not for the protection purpose. And with this, we don't need the explicit paths. You just simply send the pass message around the ring and send the resume messages in the reverse direction. Another thing is that we can allow implicit leaves. So with the traditional RCVT P2MP tunnel, we explicitly list all the leaves, one sub-LSP for each leaf. But here, in this example, we can say that the R3 is not listed in the pass message as a leaf. But if the ingress says, I'm going to allow implicit leaves, then each node can decide by themselves whether it becomes a leaf. And when they do decide so, they will send the resume message back. So by the way that the ingress indicate that it allows the implicit leaf is simply list itself as a leaf and then send the passage around the ring back to itself. When it goes around the ring, each node can decide whether he wants to join the tunnel. Now, for the protection, we don't need any additional signaling or state. We just rely on the global repair. But before the global repair finishes upon a failure, we don't send tear messages to tear down the tunnel. Instead, we will simply tunnel the traffic from the point of local repair to the next node in case of link failure, or to the next node in case of node failure. I have an example of link failure case here. We have R2, R3, R4 are the tunnel leaves, and if the link between R2 and R3 breaks, then R2 simply tunnel the traffic using the ring LSP in the other direction to the next node, R3, and then traffic will continue on. So with that, we don't need any additional signaling for tunnel protection. Finally, live protection. When we use tunnel to provide multiple services, sometimes some services with critical, mission critical services, they want live protection. Typically, that requires you to set up two tunnels along the disjoint paths in the general topology. But in case of RMR, in most situations, we don't leave live protection because we can quickly tunnel the traffic around when we detect local failure. But if you really need live protection for your mission critical scenarios, as long as the application can remove the duplicate packets, then this can be easily done by setting up two sub-LCPs in two directions that in each direction we will reach all the tunnel leaves. And in that case, the ingress will simply send the traffic in two directions, and each node, each leaf will deliver the traffic, the duplicate traffic, to the application who will receive the duplicates. And finally, NP2MP can easily be done as well. We just add a label to the pass message that is used for downstream nodes to send traffic upstream. So that was just high-level concepts. And to achieve those, we add one RMR object in the pass message to indicate that we want to do this optimization. That object will include the ring ID and ring direction, and also the source to leave sub-LSP descriptor list will list the explicit leaves or the ingress itself if you want to allow the implicit leaves. And pass message could also carry a label for the MP2MP purpose. I forgot to mention earlier that all this optimization are good, but not necessarily. If you don't care about the advantage of this optimization, you can still use the existing one without any changes. The existing solution work as is, but these are just optimization. So the next steps for this document is obviously we want to seek comments from the working group, and then we will publish the document, and then we'll request adoption. I was reminded that this probably belongs to TS, and we have TS chair here.
Pawan Biram, speaking as TS chair. I'm sure you would ask this question, so I thought I would walk up. So we do have the P2P version being discussed in TS. I don't see any good reason for this not to get moved to TS as well.
Adrian Farrell, I may be the only person who contributed to 4875 who's still left alive. 4875 was the RSVP TE point-to-multipoint work. And I just want to ask, is the SL descriptor, you didn't contribute, you were in the room. Is the SL descriptor here actually unchanged from 4875? Because 4875 allowed you to do this path message compression. So one path message would cover all of the shared upstream, up tree work. So is this SL descriptor the same?
It is the same. No change here. It's just that in the traditional mesh signaling, when you include multiple leaves in the same sub-LSP, the operation becomes, the signaling and processing becomes quite complicated. So typically, you just include one, you have one sub-LSP for each leaf. And in that case, the descriptor only lists one leaf. But here, we just list all the explicit leaves and optionally list the ingress itself in case of implicit leaf.
Right. So that aspect, and there's a lot in this work, but that aspect is just one of the variants in 4875 unchanged. Yeah.
Correct. Yep. So this one is about the multicast in general. We focus on RMR P2P previously. Now it's just the multicast in general. So this is intended to be an informational draft, at least for now, just to discuss multicast in the presence of RMR. The first thing is the multicast work as is in the presence of RMR. You do not need to do anything if you don't care about optimization, but there are optimization could be applied for certain cases. Also, we want to talk about two scenarios here. One is that the multicast domain itself, the entirety is a single ring, or the second one is that the domain is a general topology that has one or more rings and some non-ring topologies in there. Additionally, I want to introduce this concept of services and transport. The multicast service is like an end-to-end SG or a star G multicast that is either in the global table or default instance, or in VPNs, which could be MVPN, EVPN, VPOS, things like that. The next one is the transport. Basically, the tunnels that is used to transport packets for the multicast services. This includes provider tunnels for MVPN, EVPN, VPOS, and GTM when it is achieved using MVPN procedure. The next one is MLDP in-band signaling. that is used to transport end-to-end multiple service through some LDP domain. Finally, in case you're doing MLDP over RCPT, then the RCPT P2P tunnel could be used as the base tunnel. So all those are the multicast transports. So in case of PIM or MLDP, there is no need for optimization at all, except that tunnel protection for MLDP could be optimized, very similar to P2P, RCPT, P2P tunnel protection we talked about earlier. And whether the multicast domain goes beyond the single ring or not, it does not matter. The reason is that the PIM joint messaging or MLDP label mapping, they, as designed, they just get merged as they go upstream towards the root or the source. And whether you have a ring topology, it does not matter. So there's nothing to be done there. And here, the PIM can be for both multicast service or the transport. And while the MLDP is basically the transport. Then RCPT P2P tunnel, where the previous presentation we talked about that. Here, the tunnel is for transport, either for multicast services or as the base tunnel in case of MLDP over RCPT P2P tunnel. So the previous presentation is assuming that the RCPT P2P tunnel spans only a single RMR. If you have a tunnel that spans beyond the single RMR, we can still do optimization over each ring, but it needs some help of either using the segmentation procedures specific to the services, for example, MVPN segmentations, or we can build in some signaling enhancements into RCPT P2MP to help the optimization of this P2MP tunnel that goes over multiple rings. We need some further pondering on that. That is some ongoing work. And then tunnel protection, whether it's MLDP tunnel or RCPT P2MP tunnel, we don't need any additional signaling. We just talked about it earlier, so I'll skip that. Live protection, same thing. So this is it. Seeking comments, and we'll polish the documents, and then we'll request the adoption, not now.
Okay, thank you. Any questions? Don't think so. Okay, so next up is Deborah. So this is I would call it an invited talk. I have, over the last year, a little bit more, actually being rather frustrated by all the things that we actually miss in drafts that they actually submit to the ISD for publication. It's everything from acronym expansions to statements that is kind of not necessary in the document, actually flaunting actually talking about other technologies as deficient. So I think that don't belong in the document. So I asked Deborah to give a short talk about what we should do prior to working group last call and prior to request for publication to actually improve the quality of our documents. Oh. What's happening?
Okay, so this should be short, so we'll pick up some time. It's Laura introduced it. He asked, actually, so he's an anonymous chair. And I must act, Adrian talked on this about 4 years ago, so I guess it's timely again. I put the don'ts first because there's only a couple of them. It's don't expect others in the chain of reviewers, and there is quite a long chain, right? You have your working group last call, document shepherd, reviews, routing area directorate reviewers, AD, IETF last call, other area reviewers, ISG, RFC editor. But don't expect them to fix your document, especially technically. Maybe they do, maybe they don't. And don't expect Diana to clean up your IANA section. Don't hesitate to ask for help. If you're not sure what to do or how to interpret something or respond to a comment, just ask your chair, the document shepherd, AD, anybody you want. You know, don't be afraid, you know, okay? Especially if you're a new author. And if you're an author of a document actually going through, don't go to sleep after working group last call. There's much more to be done. It's for the authors to respond to all the comments that come up as the document progresses. And the document's not going to progress if you don't respond. Okay, do's. So read your document line by line and check the figures. The document has evolved, so often sections get duplicated, moved around, figures are inaccurately labeled. And during the chain reviews, it's really dismaying when a Gen Art reviewer says, your figure is mislabeled, you know, that we didn't even pick that up. Okay, so be very careful that you yourself go through your document. And then, as I said, ensure one of your authors is going to hold that pen. It doesn't have to be the same one all the time because we all take vacations. So just be sure there's somebody available, right, to respond. Because you are the ones that are the experts on that document. You know how it came about. Often, sometimes the questions come about. They'll say, well, why didn't the working group consider this? My idea is much better solution for you. And it's for you, you can answer that history question of, well, why did we end up where we did? There was a educational tutorial on Sunday, just at this past March meeting. It's what makes a good internet draft. It's by somebody we know very well. And if you don't know, and also Spencer, it's excellent. So make sure you review it. And review it again, because I cannot put everything in here in what they have. Make sure you know your RFC style guide. So these are all just pointers just to help you out, right? Ensure number of authors is 5 or less. We've been getting a lot of pushback from the rest of the ISG. I try to, when I really know I can support, and your chairs can support having more than 5 authors, that we try to get it through, but there's really a huge pushback now on that. So be really careful on it. Even and then the other part is abbreviations, acronyms. You may know them, but others, it's always picked up in the different area reviews. And they go to this list, the editor's abbreviation expansion list, and they say, well, it's not there. And even if it has an asterisk, which there's very few, you know, you should spell it out the first time. So go on the side of caution, try to spell these out. And for a lot of you, I think you're not realizing, but there's a new RFC to refer to other than the 2119. You should be also referring to 8174. So here's the paragraph that you should be including, because again, other area reviewers are going to nitpick and say, oh, you know, you don't have the correct statement there. Okay, security. This has come up over and over. The security folks they have gotten much more verbose. So make sure you are. Don't just have 2 lines and say, oh, this has all been handled before. There's nothing new. They need to know why your understanding is that there's nothing new. So put a couple of lines there, and then we'll work on it with them to see if it's good. But you'll prevent a lot of trouble if you just put more than 2 lines there. And also the management guys are getting much more careful and nitpicky. So make sure you say something, you know, is there any management considerations? And then as Loa pointed out, what we also see is this idea of the neutral point of view. And this actually came out on another document, not in our area, but that was going through. and there's a lot of discussion on it. So just be careful. There's a lot of guidance on it on Wikipedia, and it's very interesting because it gives a lot of editorial suggestions. And because as Lois said, there's no need for us, by the time we get this working group document as a working group document and through our area, right, we don't have to bash other IETF technologies. It's no longer selling our document. It's already on the publication track. So make sure you take that neutral point of view. And of course, run ID nits and carefully review and fix them. We get a lot of them that we run them and they're all there. So it's a given. And that's it.
Okay, thank you. Just one point. The abbreviation list is available off the style guide page on the RFC editor. I did a routing directorate review just the other week, and I actually found a couple of acronyms that I thought were asterisks in the in that abbreviation list, and I didn't check until very late, and to my surprise, I found they were not. So things we use daily is still not
Here.
Yeah, daily here is not asterisk in the list, so need to be expanded.
And actually, the reverse too, you may want to check that list before you come up with a new acronym. We had in DetNet that they came up with an acronym that that is famous, and it's in there with an asterisk. So make sure actually you do the reverse check that you don't come up with an acronym that is already on that list. Okay, so.
Yeah, that's the other part. If you come up with an acronym, make sure it's not one that is asterisk in the in the style guide. Yeah. Duplicates are allowed, but
Not desired.
yeah, no. So next is so Hanyu? Or
Are you some? Here we go. Sorry if I misconnect you.
Yeah, good morning, everyone. So today I'm going to talk about MPLS extension header for in-network services. First, quote from IETF 90 on the talk about MPLS architecture and principles. It said, no idea is so bad that it won't be proposed over and over again. So hopefully the idea I'm proposing today is not too controversial. And indeed, it backed up by several important use cases. And also, it opened the door for future innovations on MPLS data plane. First, though, we try to learn something from IPv4 to IPv6 transition. Actually, this work is inspired by IPv6. We think the momentum gained from IPv4 to IPv6 is not because of the expanded address space, but mostly it's because of the extension headers supported by IPv6. So due to the extension headers, now we can support a lot of new applications very easily for security, for segment routing, for in-network services such as FC, in-situ OEM, and even network programming. But IPv6 is not perfect because its overhead is too big. Only the base header is 40 byte long. And also, it's not very easy to access the inner packet if you need to scan through all the stacked extension headers. On the other hand, MPLS is very cute, right? But because it's cute, it also make it very difficult to first to know what's the upper layer protocols type. Also, it's very difficult to encapsulate new headers and metadata. The room for innovation is very tiny, and also we face backward compatibility issues. So here we actually try to design a general mechanism to solve a lot of existing problems, also create a room for the future innovation. So we think the time is coming. Now we can see a lot of in-network services need to be supported by Mpls. Such services means we need to add some metadata or new headers into the packet. This packet is not seen by the end users, but it's only consumed by the networks. To name a few such applications, like the in-network in-band network telemetry or in-situ OEM, network programming, and DDoS prevention, there are many more such possible applications. And often this application need to be stacked together, which means we need to insert more than one type of headers in the packet. Also, we need to support the backward compatibility. Also, the performance consideration is very important. For example, we need to avoid unnecessary label stack scanning. Also, we want to quickly access inner packet if we need. There's are ways to achieve that. First, we can just introduce a special extension header label. So far, there are 8 allocated labels. So we can pick one. We think the use case is significant enough to deserve one. The second method, we can use a 2-label scheme. First label is an extension label with label value 15 plus extension header label. It's okay, but we need one more label. It's not as good as first one. So the third option is we use FEC, dual FEC labels to indicate one of the label is used to indicate the existence of extension header. But it avoids the trouble to introduce a new label, but it actually complicates the control plane design. So to summarize, we prefer the option 1. So here's an example packet format. So the first part is Mpls label stack. You can see the extension label can be located in anywhere in this label stack. And following the Mpls label stack is a header of extension header, which basically tell you how many extension headers we have and the total length of it. It also indicates what's the type of the next header. And after that, as we can see, a stack of extension headers. Each header, you see the format is very similar to IPv6 extension header. It starts by a next header field to indicate what's the type of next header. Then it's followed by the length of the current header. And after this extension header stack, we can see the original inner packet followed. So some details. The first, this extension header label can be located in anywhere in the label stack. So if we want to support the backward compatibility in the legacy Mpls network, and it needs to be at the bottom stack. But otherwise, if the whole network is already upgraded, and it can be any location, prefer to be close to the top of the label stack for performance reasons. And also, we need to introduce 2 special next header values. The first one is none, which means there's no more extension headers. In this case, you have only extension headers in your Mpls packet. There's no even payload or up-layer protocol. The second special value is unknown, which means to be compatible with the original Mpls design, because we don't know what's the actual payload type encapsulated in Mpls packet. And also, we can support the load balancing in 2 ways. The first, just use entropy label. The second is since we provide quick access to the upper layer protocol, you can skip the entire extension header and to access the upper layer protocol, then you can retrieve the 5 header IP tuples for the load balancing purpose. It's very easy to do that. So the conclusion is we think Mpls is ubiquitous, it's widely deployed, and also it has a very low overhead. That's because so we think it has a better advantage over the IPv6. But also, it's very difficult for MPLS to support in-network services, especially when we need to stack multiple service headers together into a single packet. Therefore, we propose this flexible and extensible solution to introduce the MPLS extension headers into MPLS. And we believe the use case is strong enough, so we think it deserves a special label to be assigned. Also, we are also developing some new applications and use cases which can take advantage of the MPLS extension header. So we definitely need more feedback from the community. Thank you.
Any questions?
Robin from Huawei. So this, in fact, so this is just some this the important new work we try to propose under the framework of MPLS path programming. I mentioned in my presentation, since we need to carry this the metadata, not only the label stack, so that we must need some this the new encapsulation method. So I think this is the one work related with the forwarding plane. But for the control plane, so I think that is also download the label stack. But because here you some this metadata for, and also for example the NSH, it download the flow ID, so that the BGP not only download the label stack, but also some this the flexible group of the ID information. So that's the major things. Okay.
Justin, sure. So, given the amount of work put into entropy labels and similar solution, do you plan to work on all the control plane extensions to signal capabilities, signal ability to read, push, pop special labels, and you need to build larger ecosystem around the solution. So remember, your egress router has to pop everything you've pushed at ingress.
Yeah, so definitely you need the involved control plane to insert the extension headers. So it can be anywhere within the network. Right. So if it's a forced extension header, then you need to actually insert this extension header label into the label stack. If there's a last, you will remove the last extension header, then you also need to remove the extension header label. So there's a detailed processing procedure described in the draft.
Which describe forwarding plane. You really need control plane extensions to make this work.
Yeah, it's only forwarding plane, data plane procedure. Yeah, we didn't talk about the control plane yet.
And since you are stating it could be not at both, but anywhere in the stack, there's huge amount of implications in the way you fetch labels, in the way you process them, how entropy population works. So there's a lot of corner cases you would need to address.
Yeah. Thank you.
So just a small comment from someone that has to take care of the special purpose labels. It's not critical, but we are, it's a scarce resource, and we should be very careful about assigning them without a careful discussion. And I think we need a good discussion on the mailing list before we actually can go down this way. And you should also look at if you can use the extended space.
Mm-hmm.
Gives you an extra label, but if you can do that, it's much less of a problem.
Yeah, but we list all the pros cons for all the options, and we need an extensive discussion to pick one.
Yeah, but it's pretty much an on-the-fly table. That I think we should go over that table very carefully and actually add the information to what is actually said in the table in the draft.
Yeah, right. Thank you.
Thank you.
I know you'll probably file IPR against it at some point. I think I have a patent like 5 years ago on exactly that. You might want to assess it before you do so.
Okay, thank you.
So, who's next? Faisal? You here? Yep. No? You have two drafts to present. I will inform you on one thing before you start, and we actually discussed between the working group chairs on the draft that is a spring overlap, and we actually said that this one will actually be progress in spring, so it will not be here. So you will only need a very short overview on that draft here.
Sure. Yeah, it is very short in any case. So, okay. So the first one that I have is sub-TLB length clarification. So you can go to the next slide. So the issue is that 8287 defines SR IGP prefixed and adjacency set facts, but yeah, so in this case, it has it defines the facts, but the length of the fact was not very clear. Like how should it include the reserved field or should it not include it? And this resulted in some interoperability issues identified in EANTC because vendors have started implementing it. So now we are starting to see these kind of issues. So as an example over here, now we have IPv4 prefix, and then prefix length and protocol. So should it just be 6 bytes long, or should we also include the reserved field, making it 8 bytes long? So this draft just clarifies that part. So what we're saying is that it should include the reserved field, because that also conforms with the fact definitions, let's say LDP or BGP facts defined in RFC 8029. So in this case, for example, for IPv4 prefixed, the length will be 8. Now for IPv6, length will be 20. It should also include the reserved field. And then lastly, the adjacency set fact. So over here, the length, of course, depends on the type of adjacency that we have, parallel versus IPv4, IPv6, and whether we're using OSPF, ISIS, or any. So this is the table that will outline the length fields in that case. Yeah, so I feel the draft is very well documented. It identifies a problem area and provides a solution. And if there is any feedback from the working group, we're interested in it and we want to address it. And otherwise, we'd like to call for working group adoption. We'll also send an email onto the working group mailer. I guess everyone likes it. So. Okay, so this is the second draft where we are addressing flexible algorithms. So this was also presented in spring yesterday, and now I'm also presenting it to the Mpls, and as Loa mentioned, it will progress in spring. So the issue that in hand is that 8287, as I mentioned, defines the IGP prefix for IPv4 and IPv6. So this prefix is combined of the prefix value, the length, and the protocol. But now in the LSR, there's a flexible algorithm draft where a same IPv4 prefix or IPv6 prefix can be associated with multiple prefixes, each associated with a particular constraint path. One may be the shortest path, IGP shortest path, other may be the low latency path, and so on. So as an example over here in the topology, we have all the nodes are participating in default shortest path one, and then the green nodes are Algo 128, and then the red ones are only participating Algo 129. So let's say we want to issue a trace route from node 0 to node 9 on Algo 128. So when packet reaches node 1, so in the target fact stack, it only has prefix, prefix length, and protocol. It doesn't carry any algo identification. So node 1, of course, will look up the default prefix, and then it will complain that the local label value of the prefix does not match with the received label, and it will result in an error notification back to originator, result saying that LSP is broken when LSP is perfectly fine. And you can also have a case where a node is not really participating in the particular algo because we're only checking default one. So we are correctly saying, yeah, this is all good when the LSP is actually broken. So the solution is really simple. We have 16 bits of reserved field. So we can use the first 8 bits of it to carry the algorithm ID. And because the default is 0, so even if someone is running an older version, they don't really care about flexible algorithms, so they can ignore it. So this is practical and then also backward compatible. So now when we send the request to node 1, we can, in addition to prefix, length, and protocol, we are also carrying the algo ID. So prefix 1 can do the proper validation with the prefix, the next stop, and prefixed label of the particular algorithm instead of the default one, and return the correct error code. Yeah, so this is again, we feel that this is a really simple solution that addresses a valid gap. And we presented both Spring and MPLS. We're looking for feedback. It was just published just before IETF, so I know a lot of people would not have had a chance to go through it. But if you have any comments over here, you can post it to the mailing list. I will be very interested in it. And then if we don't find anything obvious, then we'll call for working group adoption in Spring. Any question? All right, thank you.
Oh, you have a question on the...
Sure.
Dhruv from Huawei. I have a question on the previous presentation, if you don't mind, which was regarding the errata draft. So this is a process question. Is that better to do a BIS document, or do we want to do it as a document / errata, which updates the clarification that is missing in the original RFC? So some guidance to the authors would be nice, whether it's better to follow the BIS procedure or they want to do it in the current approach, what they have.
So I don't think there is something that fit all cases in this. I think we need to think about it, and I know that at least Carlos is willing to discuss how to do it. This is not a normal errata to start with, so it requires a draft. It should be a BIS or not, I'm not sure, because sometimes when you do BIS drafts, you actually pull down so much extra work, so you can't really do it. We tried LDP once, and the update from what is actually there was pretty easy, but actually everything that we had as a backlog actually killed the work. So I'm not sure, but I think it's a good idea to post this to the list. Okay.
All right, thank you.
So that's the end of the agenda. Thank you all. If nothing else, we see you in Bangkok, and safe trips, and see you again. Yeah, it's very useful. Nick is usually doing it. It's not that careful as you were. It kind of
Your machine is operated. It's time.
Thank you very much. Are you taking care of the? Oh, the other way around. Back. You take it on to the secretary. Well, I can do it. Huh? Okay, you get you to the registration desk. Say, I have an issue. They say, there is a box with the address.